Welcome to the Insightful Professor. In this video, we continue our examination of conditional logic in Java. This time we're going to be focusing on logical operators. What logical operators allow us to do is to combine simple Boolean expressions into more complex Boolean expressions. And this is going to be a pretty useful capability that we want to present today. So we talk about a Boolean expression being simple, where we have something such as x is greater than 2, comparing the value that's currently in the variable x against some other value, in this case a literal. Remember, that evaluates to true or false. That's why we call it a Boolean expression. But we can combine two or more Boolean expressions into what is called a complex Boolean expression. This is where the logical operators come into play. The operators we have are referred to as and or. However, in the language of Java, they're not spelled out and or or. They're spelled as these kind of odd-looking characters that don't really seem to relate to the concept of and or, but this is how they're expressed in the language. Two ampersands represent the notion of and, so that is the and operator. Two vertical bars represent the notion of or, so in Java, this is the or operator. Now, to evaluate a Boolean expression that is complex, what we want to do is consider again how the simple Boolean expressions are evaluated. Then we can better understand how to deal with these complex expressions. Remember, as we have a Boolean expression such as x is greater than 0, there are two possible evaluations. Either the value that x contains is indeed greater than 0, so the expression x greater than 0 would evaluate to true, or the value in x is not greater than 0, hence that expression would evaluate to false. If we combine these two possible values of true and false for two simple Boolean expressions, we have 4 possible results to consider. For 3 simple expressions, we have 8 possible results, and so on. Let's take a look at what I mean by this. If we have 2 expressions and say we refer to the expressions as P and Q, P could be true or false, Q could be true or false, and we consider the possibilities of how these could combine, we end up with P perhaps being false and Q being false, or P being false and Q being true. But on the other hand, P could be true, and in the other 2 situations, Q could be false or true. Hence, for the 2 conditions, the 2 simple conditions, we end up with 4 possible evaluations. When we have 3 expressions that are connected, then we have 3 possible outcomes for each of the individual or simple conditions, each one being true, false, or true, false, or true, false. And when we look at the way these could combine, we end up with the 8 possibilities shown here. These possible combinations can be used to form what's called a truth table. And when we use our Boolean connectors, or logical connectors of and or, then we're going to say how these various combinations evaluate. That's where we use these tables that we're showing here to build what are called truth tables. We'll see that in just a moment. So let's look at the 2 possibilities of and then or. What we'll do is we'll start with 2 simple expressions that are connected using and, which again would be the double ampersand, and this forms a complex expression. Just as the simple expressions can each evaluate to true or false, the complex expression also, being Boolean, will evaluate to true or false. The syntax for coding something of this sort is shown here. Notice we have a simple expression within the parentheses, a second simple expression within parentheses, and then we use this logical operator of and, so the 2 things are going to be anded together, and that whole thing forms a complex Boolean expression, which again would be enclosed within parentheses. Here's an example where we're comparing the value of x to 0 to see if it's greater than 0, and likewise comparing the value of y to see if it is greater than 0. And we're looking in this case to test both conditions. What we're saying is x is greater than 0 and y is greater than 0. and then we're going to evaluate this. Let's look at how this would go with a truth table. Now let's consider how these two simple expressions combined to form a complex expression will be evaluated. We again talk about the truth table, and here we formally present one. We're saying, remember, we have the two possible expressions here, each of which by themselves could evaluate to true or false. The possible combinations then would be false, 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 true, true, false, true, true. What we're looking at when we use and is a situation where the complex expression will evaluate to true only if both of the individual simple expressions evaluate to true. Hence, there's only one possible combination here that will yield the value of true. It's only when the first expression and the second expression evaluate to true that this combination evaluates to true. Now, this is the concept. Putting it into Java, we look over here and we say we again are looking at x greater than 0, y greater than 0, and here's our expression. So we're saying test x greater than 0 and y greater than 0. And again, the whole thing is enclosed within parentheses because this complex expression, just like the simple expressions, will also evaluate to true or false. Let's take it and look at OR. With OR, we're saying we could have two simple expressions, once again combined, but this time we're using the double vertical bar representing the logical OR operator. So again, we have a simple expression enclosed within parentheses, simple expression within parentheses, combine the two with the OR operator, and we again enclose that entire complex expression within parentheses. And we're using a similar example here for our Java syntax, again using the double vertical bar. Let's look at the truth table for this. What we're looking at now is we've got the two expressions which we're calling A and B. The value of the complex expression, A or B, will be true if A is true, or if B is true, or if both are true. So looking at our truth table, we see that when they're both true, when the first one is true, when the second one is true, each of these situations yields a true. It's only when both of the individual conditions are false that the complex expression also evaluates to false. And again, we're using our Java syntax example over here. We have talked briefly about the not in our earlier video, but let's look at it more closely now. Not is, instead of being what's called a binary operator that involves two expressions, it is referred to as a unary operator because it operates on only a single expression. What it really does is it negates the value of the Boolean expression to which it's been applied. So here we have temperature greater than 100. We precede with the not operator that negates the expression. Hence, if temperature greater than 100 evaluates to false, not temperature greater than 100 will evaluate to true. If the expression temperature greater than 100 evaluates to true, negating it with the not operator will produce a false value. And again, here's our truth table. What we're really showing is a simple toggle. If you start with true and you negate it, you get false. Start with false, you negate it, you get true. And this is because we're using a two-value logic. We have only true and false as our possibilities. So let's summarize the operators that we've just introduced. We have the AND, which is expressed as double ampersand, and this combines two expressions, two simple Boolean expressions, into a complex expression. Again, the result of the complex expression will be true only if both of the individual expressions are true. We have the double vertical bar, which is the Java syntax for the OR operator, combining, again, two Boolean expressions. That means both AND and OR are binary operators. So it combines the two Boolean expressions into a complex expression that evaluates to true or false, depending upon a different situation. If either or both of the individual expressions is true, then the overall complex expression is true. And then we have the not, which again is a unary operator, effectively toggling the value of the expression. One more important thing regarding the logical operators and Boolean expressions in conditional logic, we can declare a variable of Boolean. Remember, Boolean is a data type in Java, so we can declare a variable of that type. And here's an example. We declare this thing called isPositive, which is of type Boolean. So here what we're doing is testing the value of this integer variable. If the integer variable is greater than 0, then this expression is true. The result of evaluating this expression, in this case we say it's true, would go here. If the result of evaluating this expression is false, then in that case the value goes here. So the point is the expression can evaluate to true or false, and what will happen is the result of that evaluation will be stored in this variable. It's designed to house a Boolean value, true or false. So the neat part is we're able to take the result of evaluating a Boolean expression, again being true or false, and we can place it into the variable. Again, in our example, we have -5, so -5 is not greater than 0, hence the value of the expression is false, the value of the variable likewise will be false. Once a Boolean variable has been assigned its value, we can then use the Boolean variable the same way we could use a simple or complex Boolean expression. Simply enclose it within the parentheses and we'll be able to test it. Now, we haven't shown how to test it yet. That's coming up in one of our next videos, where what we'll be looking at is using these Boolean expressions to drive the flow of control within an application. We'll be looking at a statement called if, and we'll be looking at a statement called switch. One additional thing to consider, just for completeness in understanding conditional logic, is something called short circuit analysis. This is very relevant when we're talking about and or for logical operators combining simple expressions or simple Boolean values. It's possible that, as we looked at our truth table, the first expression in an and type of operation could be true. Then it would be necessary to check the second expression, because we need to see that they're both true in order for the and operator to yield a true value. But consider what would happen if the first expression in an and type of operation was false. There wouldn't be any need to look at the second one, because if one of them is false, it doesn't matter what the other one is, because the definition of and says both conditions must be true. Therefore, what the Java compiler does is it employs this thing called short circuit evaluation. If it sees that you have two things that are combined with and, it knows that both must be true in order to go down a certain path of logic. Therefore, if it evaluates the first condition and sees that it's false, it doesn't waste its time executing instructions to evaluate the second operation. That's what's called short circuit evaluation. Similarly with or, we need only one of the two conditions to evaluate to true in order for us to say that the overall complex expression is true. Therefore, if the first expression evaluates the true, there really is no need to evaluate the second expression, because we already know we've come in with a verdict of true. There's another concept here called complete evaluation. Short circuit evaluation is very nice. It adds, say, a degree of efficiency or perhaps what we might call optimization to the code. For complete evaluation, we can use a slightly different operator. We can use a single ampersand to represent and a single vertical bar to represent or. When we use these operators instead, short circuit evaluation does not come into play, but complete evaluation is being requested, and the compiler will accommodate us. But keep in mind that in most situations, short circuit evaluation and complete evaluation will produce the same result, but there are some situations where it will be different. Suppose we had an expression such as x divided by 2, and we're comparing that with some value, or say x divided by y, and we're comparing that with some value such as 2. So let's take x divided by y, see what the result is. Then compare that result to see if it's greater than 2. So this is a Boolean expression. Now, in order to evaluate this, we actually have to do the division. Suppose the value of y at the time this expression was evaluated happened to be 0. We would be attempting to divide by 0, which is not acceptable. So what would happen, x divided by 0 would be evaluated. That's causing an overflow in the system. An exception is thrown, and the code or the execution effectively aborts. It's an error. So therefore, if this was the second condition, say in an AND, where the first condition evaluated to false, with short circuit evaluation, this would never be evaluated. But with complete evaluation, it would be evaluated, and that would cause a runtime error. So there's a subtle difference, but an important difference to consider. So let's summarize what we've done here. We've introduced additional concepts related to conditional logic. I say these are additional concepts because I assume you've watched the previous video. We've introduced logical operators. These are used to connect simple Boolean expressions to form what we call complex Boolean expressions. We introduced truth tables for these logical operators to give us a way to figure out how to evaluate the complex expressions. And what we saw was we have AND, which in Java is 2 ampersands, the OR in Java, 2 vertical bars, and the NOT in Java being the exclamation mark. We showed the use of Boolean variables, and then finally we explained what short circuit evaluation is and what complex evaluation is, and told you some important points about that. So hopefully you found the video interesting and informative, and if you have any comments, we'd be glad to hear what you have to say. And also, if you liked the video, give us a thumbs up. And furthermore, consider subscribing to the channel. We're going to continue posting videos, and this will give you an opportunity to be made aware when we posted them. And once again, thanks for watching.